everyone. Today we have our another new episode and our sessions on renewable energy innovations. We have our world famous speaker, Mr. Dan and Mr. Robin Daly. World Talent Economy Forum. We are closely working with university grant commissions, different embassy like US Embassy, uh, like Commonwealth, like Australian government agencies, Australian trade and commerce industries, and everybody supporting World Talent Economy Forums. I want to give a special thanks to all of our speakers, those who continuously join World Talent Economy Forums and help us to grow. And now more than 100 universities, they are collaborating with us and they are utilizing our content as a case study. And what you are discussing, it will be helpful for our national policy development. So for that particular issues, we are working just recently, we are working with Curtin University and North South University and Australian Embassy, specifically for renewable energy innovations and agricultural innovations. So today we're going to discuss on that particular issues, and our issues will help Bangladesh government and Australian government to build up the policy and strategy for our country. First, I would like to give chance Mr. Dan. Mr. Dan, what you want to discuss about today's session?
Yeah, energy innovation is going to be very crucial moving forward. We're a society that measures its progress really in energy. And in fact, it was once proposed by famous scientist Buckminster Fuller that we should have a world monetary unit based on the kilowatt hour. This kind of thing's been proposed before. It's kind of a technocracy kind of a proposal. But really, energy is the currency of the modern world. And I've spoken earlier about the idea of a world energy grid. There's actually a foundation or an organization which called GENI, which is the Global Energy Network Institute. I don't want to do too much promoting of things. I know we have an issue with promotion, but yeah, conceptually, it is possible to have a global money standard based on the kilowatt hour and a global energy grid. Now, how do we fill in the missing parts of our energy grid? We have a lot of exciting new technologies. I like the small modular reactors, so-called generation 3 and 4 nuclear reactors. Nuclear has a very large stigma to it because it was done kind of haphazardly before, where the full safety protocols weren't strictly implemented. But on these later next gen reactors, they are able to recycle nuclear waste in some cases. When a traditional light water reactor pulls the spent fuel rod out, it's still about 90% radioactive, plus 90 plus, I think. And that's just because it's not producing as efficiency the concentrated level of energy that they're looking to produce. But if you're dealing with smaller modular reactors that are producing, say, energy for a neighborhood, you don't have to have these extremely dense, high concentrated power requirements, and that's one thing of them. And we've been building these things since the 50s, ever since nuclear reactors and experimental research reactors. So unfortunately, countries like China are pretty much technological leaders on that. So we've got some catching up to do here in the West. But I think global cooperation can dispel some of those fears about which country's ahead and what. Another thing is some of these next gen reactors can use thorium, which is incredibly abundant, far more abundant than uranium, or thorium is actually what makes a lot of coal burning plants more radioactive, because thorium occurs with coal. And when you burn the coal, you get these thorium particulates as part of the plume. So that's pretty dangerous, because thorium is radioactive naturally, and if it's inhaled, you've got this source of radiation now sitting inside your lungs, which is probably gonna induce a lung cancer at some point. So that's kind of an interesting little point that people have made about coal plants being more radioactive than nuclear plants. Coal is, of course, very problematic. I was kind of sad to watch the debate last night among the Republican candidates, and one of them was saying, "Oh, you've got to do oil and coal and natural gas." So no, that's not the right solution for the energy mix, in my opinion. Uh, but as far as other energy innovations, some of these innovations are going to be economic and social. There's a UC Santa Cruz professor, Robert Staten, who has a plan that not only produces solar power, but also a universal basic income from the solar power. And this is kind of a community level thing where you build solar farms and you give people shares in the farms, and you actually don't give them the money if they're under 18. You hold that in a trust fund, but it also involves putting the price of a kilowatt at $1 a kilowatt hour, which is probably higher than it is in a lot of places now. But it's just a way of standardizing this, and if you price at that and you follow this plan at solardividends.org, you actually end up phasing out fossil fuels worldwide in 3 generations or less, and creating a universal basic income for everyone on the planet. People like fusion power. Well, we've got the ultimate fusion source 93 million miles away, where it's all self-contained and it's not polluting our biosphere with nuclear fuel. So solar power is nuclear power ultimately. So if you're afraid of nuclear power, you're afraid of the sun. But it should be done in a way that there's no waste, and zero waste. Of course, waste is a resource out of place, what we call waste. But a lot of other interesting solutions is that some of these nuclear spent nuclear products, so-called spent because they're not really spent, they can be encapsulated into small batteries, and they can have actually like a diamond substance around them. There's a company that's doing this to create small power sources, and it's not a really dense power source again, but it's good for things like clocks or computer memory batteries. So that's an interesting technology on the other end of dense centralized energy. But yeah, I'm a fan of decentralizing things. I'm a fan of cutting the middleman out wherever possible, and I'm a fan of making things open source. In other words, making the plans transparent and freely shareable. The Creative Commons license is a great innovation for doing that, where you just have different flavors of license where you can make it commercial, non-commercial, okay to modify with permission. Anyway, there's all the flavors of Creative Commons licenses that you might want to use, and that's part of the open source movement, which I'm a big fan of, and I think that's going to be a big important energy innovation factor. So those are some opening thoughts, and I'll go ahead and turn it over. Take it away, Rob.
Yeah, sure. Thanks. And good morning.
Mr. Rob, yes.
Yeah, so sustainable energy. Some interesting announcements this last week. Microsoft announced that they're looking at small nuclear reactors to power data centers. And that might be the ideal use, much like we discovered with the cryptocurrency fiasco that occurred, well, may still be occurring to a certain degree, but it's dropped off quite a bit, along with NFTs, which are now worth pretty much nothing. The issue with AI is it's using a lot of computer power, and we're still at its infancy. These data centers are going to be huge hogs of energy, and so it makes sense to place sustainable energy generation near them. In fact, this might be the first real test of whether small nuclear reactors can scale properly, because these data centers have a huge energy requirement, and if you can get them off the grid, that now unused energy becomes available to the community at large. And with hydroelectric power dropping off due to the climate change events, and wind becoming a bit more uncertain for the same result, the ability to pull some of these large consumers of electricity off the grid would make a huge difference to the rest of us that are currently living on the grid. With regard to wind power, one of the more recent interesting developments is floating windmills. We've had these oversized windmills going on off the coast because wind tends to be much more sustainable off the coast than on land in many cases. And so being able to place windmills without having to place them into the ground, which can be very costly, the depending on how deep the water is. Building a tower with a windmill on top, the part of the tower that's below the water may be more costly than the part that's above the water, and generating power, which adds to the initial cost and lengthens the payback period of the generator. If you can float those things, then you remove a substantial amount of cost, and depending on the depth of the water, it could be the majority of the cost from deploying the windmills, which would be good. And just as a side note, windmills are not driving whales crazy and causing themselves to beach themselves out of the ocean. That's made up science. But in the end, windmills are a viable alternative. There have been issues, of course, with windmills killing birds. The birds do have a tendency to fly into things. I just had one suicide on my window last week. It was very disturbing. And new windmill designs are coming out that prevent that. Some of the very large windmills move so slowly that they're not much of a hazard. But some of the smaller ones do kind of move like Cuisinarts, and so they take out birds. But we've got vertical windmill designs that seem to work in some ways better than the traditional windmills. They don't have the multi-axis failure rates that the large windmills fail, since they just rotate on their. I mean, what I'm talking about is basically it's a drive shaft that's vertical. The windmill rotates around that drive shaft, and it's more of a pillar than a blade. And at least right now, it doesn't appear to have any adverse impact on animals, particularly birds. So designs are coming up that are far more bird friendly as we move forward. Yesterday we talked a bit about solar generation. That there are at least 10 companies, I believe, now that are working on extraterrestrial solar generation, 24/7. There are issues with regard to how you maintain and repair the panels, because we have an awful lot of debris floating up there that could come in contact with them. And the other, of course, is the transmission of the power to the surface of the Earth, which is being worked. Finding a way to create enough energy density without making the energy beam lethal has been somewhat problematic. But we are making progress. And right now, the prognosis is we should have a viable test. Assuming the initial tests work well, we should have viable tests at scale starting in around 2030. So that could be a significant game changer, a low cost, 24/7, environmentally friendly. The panels are mostly glass. It's just the cost of getting up there. And there is certainly a possibility that we could use asteroid mining and orbital manufacturing to create the panels. Though we're probably more than 2 decades away from that capability, but that would lower the heavy lift cost of putting the panels in orbit. Though SpaceX has really reduced the overall cost of putting things in orbit. Now we need to reduce the overall cost of getting things out of orbit, because we have way the heck too many things currently floating around the Earth that are creating a fairly significant navigation hazard for anything we want to put up there. Some of the other stuff that continues to be viable is geothermal technology. Geothermal is, again, very green. There are some concerns that if geothermal, much like fracking, is done without proper assessment, it could cause things like earthquakes and a reduction of stability in the land masses. But it's a fairly remote problem, and it would really have to do with relatively large plants. And we've learned enough, I think, at this point to be able to do geothermal relatively safely, and certainly more safer than some of the other alternative technologies at the moment. Another alternative technology is it's taking the force of waves, the tidal force generators. Those are really promising, though of course they work best off the coast and when you have lots of tidal movement. But you generate a lot of power. Again, not much damage to the environment. Another issue with regard to maintaining it, because salt water and most materials, particularly metals, don't like each other very much. And so you have maintenance issues with regard to these below the surface generators, but we're working through them. We have ways to use ceramics, and ceramics are pretty much invulnerable to this stuff. The other issue, of course, we've got with anything you put in the ocean is stuff likes to grow on it. And of course, that's problematic for things like bearings and moving surfaces, as we've discovered with boats. And the typical way of keeping things from growing on surfaces is to use stuff like lead-based paints, which isn't environmentally friendly by any stretch of the imagination. So, but you can also use electric fields to make the surface of the material unattractive to organisms that might otherwise attach to it. And since you're generating energy anyway, that might be the best way to address the underlying problem is a relatively light energy field that repels the organisms from attaching themselves to these surfaces. And of course, as one of the things we have to consider here is lowering the overall need for energy, coming up with ways to do things that don't require as much energy as we've had in the past. And everything from using heat pumps, which is coming heat pumps for washers and dryers, to more effective heat pumps for HVAC systems, particularly with climate change. We need to find more efficient ways to cool off our buildings than we currently have. And those are all being worked. And in fact, we have some heat pump. Europe has loved heat pump based washers and dryers for a while. They just recently came to the U.S. in U.S. sizes, with GE probably leading I would argue GE's leading this particular charge with regard to those appliances. But there's a lot of potential for mitigating some of the energy uses by just promoting greener ways to use energy. LED lighting, of course, is relatively widespread now. And with some of the exceptions of some of the political parties pushing back on LED lighting for whatever reason, it's been moving through the environment reasonably well. And the LEDs, while they're supposed to have a 25-year life, depending on the manufacturing quality, they will generally outlast an incandescent bulb. But the overall quality of the LEDs has been a bit uneven. And so assuring the quality of the LEDs would be a wise move for any government looking at regulations, so people trust the technology and will use it widely. And then finally, with regard to these alternative energy sources, while we've been really good at creating them, we haven't been really good at promoting them. And with solar being perhaps the exception, but recognize we first started messing with solar back in the Reagan administration. And it had a very uneven start back then. And currently, China pretty much owns manufacturing of solar panels, which is problematic for the world, given that China is currently, well, they're misacting a bit, and they're under sanctions from much of the Western world for that misaction. That creates problems with regard to solar panel cost and delivery, because those sanctions come with tariffs. And those tariffs artificially raise the price of the panels. And right now, we want the panels to be as cheap as possible. They're as deployed as widely as possible, so we're mitigating the energy use as much as we can with sustainable sources. And so finding a way to produce low-cost, high-yield panels, but without relying on China, should be a higher priority at the moment than I think it is. The newer panels not only have far better yields. I just put up a set of second-tier LG panels on the house, and the yields are phenomenal. And the panel life is well over 20 years, which is a lot better than the first panels I put in on my last house, which had a panel life closer to 7 years. And by now, they've probably dropped so much efficiency that they need to be replaced. They're probably not even generating enough power to make the plant reasonable anymore. So a 20-year life with 90% of the power remaining is certainly more than adequate, and the panels are getting better from here. So getting a panel that could last conceivably for the life of the house or building or structure would make a huge difference here, and as well as panels that can better generate in off-light conditions like overcast. And some panels will actually generate at night, though you need a pretty strong moon for that to happen. But the extraterrestrial power is really the way I think long term to go with solar, if we can better figure out broadcast at scale and not create additional problems with the energy transfer through the atmosphere. It is interesting to note that some of our concerns with regard to the atmosphere are being changed at the moment. The ozone layer, which was thought to be a critical part of our preserving the planet, now it looks like if it's a little permeable, may actually solve some of the smog problems we're having that are causing some of the climate concerns that we've got. So moderating the ozone layer as a tool to mitigate smog may be a viable way to adjust for climate change, but you wouldn't want to do it with an energy source at scale until you were really sure that changes were going to be beneficial and you weren't creating some other form of collateral damage. The ozone layer has been pretty fragile, and we don't know yet what broadcasting power at scale through that layer would do. It's being explored. This is not something anybody's ignoring, but it's one of the things we have to consider when we start putting large scale industry into orbit. And these panel farms, these solar farms would be huge. The at a scale really never before considered for an extraterrestrial or even arguably a terrestrial plant. The scale would be at state or country scale, and that would be significant. And then finally, before I drop off, the individual efforts that we all make to conserve power and use power more efficiently are all beneficial and should continue. Expecting science to solve all our problems is never the best path. We need to consider our own usage models and make sure that whenever possible we are conserving energy. You'll notice my office is a little darker than normal as I try to walk the talk. My office is lit by partially lit by a solar tube at the moment, which is about as sustainable as you get. And we can do things like that as well. I use the existing solar energy for lighting and during the day, and reduce rather significantly our requirement for energy-based lighting. And I'll conclude. It looks like David Smith has joined us, and we'll let David Smith step in and give his opening remarks with regard to sustainable energy. Hey, David.
Hey, Rob. Thank you. Sorry, I was traveling in car and got delayed. Always happens because of sustainable energy, right? Now, renewable energy is a very interesting one today because, uh, Rob just mentioned sustainable energy, and renewable energy is kind of by definition sustainable, but in some ways it has a broader definition than that as well. You begin to understand the nuances of it when you look at the different types of ways that you can really have those type of innovations. Some of them are in things like clean energy harvesting and how you can begin to do that. Some of them are different ways of storage technology. Uh, we've talked a lot in these programs about the advances in battery technology, but also we're seeing other ways to store things with, for example, uh, materials pumped either water to a higher elevation when power is plentiful, like solar power, and then at night being drawn down through generators to generate when there's not solar or wind power available, for an example. Uh, we also see some other real interesting renewable energy innovations around the use of kinetic power. Uh, an example, Dr. Sharif, you've heard me use before, is one of the companies here in the United States that's headquartered in Florida that has put battery rail cars on rail lines and has put connected to the wheels of the rail cars, not just the battery one, but others, little generators, so that while the freight train is moving down the tracks, it's actually generating renewable energy at almost no overhead to the transport of the material which are on that. And what I really like about that one is that it has the ability to, every time the batteries are full and you're going through a town, if you plan it well and the logistics are well, to swap off the full battery for ones that are not full, hitch it back up to the train, and continue that process across the country, theoretically, as the train is making its way. Some of the other interesting renewable energy innovations is there's some new work in solar cells. And I know Rob had talked about that in a prior program, but the solar cells are having some really very interesting innovation, and we're beginning to see the production of, and I believe this is innovative in a very interesting way, hybrid solutions where you see how that comes together on there. Uh, One of the, excuse me, uh, ways to look at some of the other type of innovation is that, we're trying to transition to a cleaner and hopefully along the way a much more secure energy system. Or we're going to really miss those net zero targets there, uh, and we're beginning to see how that can play, how you can put it, how we can begin to over the time do that. Another innovation that is picking up some speed that I just have been tracking, and I'm seeing some good results in it. In Switzerland, there's a startup that has developed a AI-controlled solar energy system that they put on the outside of buildings. These panels attached to almost any building, and they can be moved. They can solar track. They can do heating, cooling, and even artificial lighting. And so it's a very interesting one that is going. And they produce it so it fits in to the environment. There's other ones, for example, another one in uh, Paris, where this company has put kinetic floor tiles in place, and the pressure of the people walking through the train station actually generates power. Uh, Again, another innovative way to look at some energy solutions uh, that I think are great examples and are ones that really help illustrate the power of innovation, the power of thinking outside your box. I mean, I would not have thought of putting kinetic floor tiles in a train station to generate power. I mean, we should do that at airports uh, because of all the foot traffic, and particularly congested airports because you're going to have a higher kinetic thing with the people running between gates. No, you see those type of things happening. But Sharif, I think this is probably a good place to pause with my opening remarks. And thank you for letting me come on late. I apologize for the traffic.
Thank you, Mr. Dan.
Yeah, those are some great thoughts about thinking outside the box. That should almost be a new form of energy, the outside the box thinking energy, because we're going to need a lot of that to solve the problems that, like we talked about. We're not on track with the 17 Sustainable Development Goals of the UN. I'd like to add that 18th one of space economy. But yeah, I mean, there's outside the box things like Rob, I love the fact that you're using the solar tubes. Ever since I saw those, I thought, man, this is like the coolest kind of skylight to have. Um, it looks like it's working out. But a lot of the energy usage is for building heating and cooling, and some of that can be offset by using passive solar, creating a thermal mass uh, for your building where the sun heats up a big pile of dirt or water barrels, or this was there were actually the earth ships that were designed by Dennis Weaver was the guy that bought, I think, the first one in New Mexico. I forget the guy's name that pioneered that, but basically they make a big wall of tires and fill them with earth, and that becomes your solar mass wall that points at the sun, and then uh, that basically cuts your heating and cooling costs well below in half, sometimes down to like 90% cut in the best case scenario. Concentrated solar is another thing that I think is neglected for energy generation. We see these giant plants with the mirrors, and they focus on the tower, and that creates molten salt that can supposedly salt will stay warm overnight, and they can keep generating power um, around the clock. And really, that's the bugaboo with a lot of renewable is you don't get the baseline power requirements that you can turn on and off as the grid fluctuates. You can match the grid demand, but like you said, the solar panel prices are going down almost by the day, and battery prices are going down by the day. So at some point, it's going to be viable for grid scale baseline load. We can have giant battery banks. I think Tesla has already put one in Australia, a grid scale um, battery backup. But again, I think building underground, building earth sheltered, that's going to be a question of your local government's building codes in a lot of cases. I think New Mexico is is the state with the most friendly building codes for building underground or building earth sheltered habitats. But again, this is not going to be a solution for everyone. Not everyone can move off the grid and build an earthship. That's kind of the high end solution. But we can cut power in cities by having high density mixed use developments, which I think are catching on. We've had a couple here in Thousand Oaks recently. They've been pretty successful. Basically, they're 3 or 4 stories with condos on the top floors and then commercial businesses on the bottom floor, and it makes a pretty quality of life kind of option instead of the single family detached home, which is kind of the worst energy offender. But people love the amenities of being around culture and other people. So this is a good way to also solve some of the social isolation problems that can happen in cities. So really, when we do innovative renewable energy, we want to look at how it spills into other disciplines and other categories, and think outside the box, like you said, David. That's going to be one of the keys, is renewing our innovative thinking. So I'm going to pass the mic.
Yeah, thanks. Appreciate that, Dan. And let's talk about innovative thinking here for a moment. And there's quite a bit going on and a number of interesting startups that are entering the segment. Starting with advanced photovoltaics. This is the solar panel generation company called Lusoco, Lusoco, is creating luminescent solar concentrators. This would allow for lighting applications. Not only does it concentrate the energy, but then the concentrators then return the energy as light when the energy is no longer there. So think of signage, lighting around buildings, things that are consuming power that wouldn't necessarily need to consume power and work much more efficiently than the solar powered LED based lighting solutions we have out there right now. Norwegian Crystals, that's a Norwegian company. We're talking about solar panels lasting longer. Their technology, which uses gallium doped ingots, would allow solar panels to last significantly longer than they last today, allow you to put them up and perhaps leave them up for 50, 60, 70 years or more and have them still be performant. Another advancement is in AI and big data. This is a case of not necessarily generating new energy, but being able to make better use of the energy you are generating, making sure that the energy is flowing to where it needs to go, and where losses and problems with energy delivery or transport are discovered and corrected, so there isn't a lot of waste. Like a Watt, it is developing a software solution that helps optimize grids and can calculate historic consumption and make better models in terms of making sure your generating capacity and consumption are better matched. Another is Resonance, Resonanz, which is creating a vehicle for intelligent energy trading between parties. so that an area, a country, a city, a region that is overgenerating at the moment can effectively and dynamically trade their overcapacity to somebody that needs the overcapacity because for whatever reason they're not getting it overcast or whatever, allowing for the better movement of that energy. And going back to Dan's earlier comment about using energy as currency, you need a trading element to that, a mechanism to allow for the trades. Distributed energy storage systems, as we've mentioned several times, that one of the big problems with regard to renewable energy is many of the renewable energy sources don't work 24/7, and so you need some type of a storage facility that is highly efficient. You don't want waste in storage, and will allow you to use that energy when it can no longer be generated. Green Y is a company that's using compressed air for energy storage. Interesting use, and certainly a bit more portable than some of the other ones we've mentioned, like liquid sodium, which isn't really portable at all, and problematic when it's hot. We actually explored liquid sodium for automobiles. In an accident, it didn't behave well. And then MGA Thermal is an Australian startup that enables thermal energy storage. And here they're using, much like liquid sodium, liquid sodium. They're using the heat to melt a metal, but they've created a unique metal formulation that allows itself to near continuously go from its melted state to its solid state. And more efficiently distribute the heat that it is absorbed, so you get a higher yield and less energy loss. Moving to hydropower, we kind of mentioned that dams are problematic because of climate change, and so moving to something like a sea-based energy system is now becomes viable because the ocean's not going anyplace. If anything, if it's going someplace, it's coming inland. And sea-based is an Irish startup that develops modular wave wave energy converters, small in form, easily installed, and they sit out as buoys off the coast generating power. Of course, you do need waves and tidal movement to make them work. But if you've got that, these things work, and probably nothing really much greener than that. And then GED. Another company develops microturbines, and this is for water movement. And the microturbines for rivers, streams, and the rest can provide, and also can be used in the ocean for tidal movement. Provide an relatively inexpensive way to capture that movement and convert it to energy. Moving to wind energy, mentioned one of the big problems with wind energy is the unreliability of the wind. Typically on land, wind is available from about mid-afternoon through early evening. It's not much middle of the night or early morning. Hydro wind energy provides hybrid energy systems. The Ocean Hydro, which is their product, is a offshore altitude, uses offshore altitude wind kites to generate power, which has to be cool. I don't know what it does for air travel. I've probably some concerns about that because some of the wind generating technologies I've seen, they have to fly relatively high, and might create issues for air traffic controllers. But it's relatively inexpensive, highly reliable, particularly if you get up into some of the sustaining winds that are at altitude, and because they're off the coast, you can keep them away from air corridors. And if it's enough off the coast, you can keep them away from recreational aircraft, which I think would be a problem with too many of these things up on land. And then a Helicold, U.S.-based startup, is developing one of the problems with wind blade quality and recycling. We had a lot of the problems with regard to the initial windmills was the fact that those blades were not recyclable, and they consumed an awful lot of resource in terms of carbon fiber. Companies like Helicold are creating better wind blades that are recyclable and much more sustainable going forward. Moving to bioenergy, which is really kind of interesting. The bioenergy stuff I don't think has been explored quite as well as it could have been. Biological entities create waste, but that waste can be consumed as fuel. Phycobloom, Phycobloom, it's a British startup that uses synthetic biology to produce bio-oil. So rather than using subterranean oil, this is bio-oil that's being generated. Now, again, any type of petrochemical product is going to create some issues, but remember, with petrochemical, you not only have issues with the burning of the material, you have issues with regard to the mining and drilling for it. Philadelphia is a case in point where there are just tons of uncapped wells all over the place, polluting the environment. This is a case where you're creating the oil from basically manufacturing the oil and using it that way, and you can change the formulation to make it burn cleaner and be less damaging to the environment. Bioenzymatic fuel cells is created a paper-based fuel cell, which is kind of interesting. Fuel cells contain carbon electrodes, enzymes, and microfluidics. And they're suitable for power generation. Interesting technology. I think it's a little over the horizon here, but relatively inexpensive to create. And the energy it creates is both green and in a way it could also be a form of energy storage. So it's a fascinating tech that's coming to market. Grid integration. We mentioned kind of grid exchanges and power exchanges. But part of when you're talking about these microgrids is how do you share the energy across the microgrids? And a company called Ageto Energy, it's a US-based startup that produces microgrid controllers that will allow these microgrids to load balance between them and more efficiently, without a lot of oversight, handle the energy requirements of the individuals that are using them. I mean, a lot of times when we're talking about microgrids, we really don't talk about the fact these things would have to be maintained and to a certain extent regulated. These microgrid controllers would be instrumental in doing that. And then we don't talk about superconductors very much, and we haven't at all. And with regard to energy transport, superconductors could make a huge difference because they don't. The thing with superconductors is you get very little or no energy loss when you're talking about transport. VEIR has come up with a line of high temperature. The problem with superconductors traditionally is they have to be kept at sub-zero temperatures, sometimes substantially sub-zero, making them problematic to use. VEIR creates high temperature superconductors. They'll operate up to 10 times the current conventional wire thermals while maintaining superconductivity. Their operating temperature uses evaporative cryogenic cooling to allow them to operate in the real world, but they're 20 times more efficient than mechanical subcooling, and so a massive increase in the capabilities of superconductors for energy transport. An interesting startup. Again, I have some doubts whether it's going to scale, but it shows promise, and it's U.S. based. Green hydrogen. The green hydrogen. I think we really missed something with regard to hydrogen. Hydrogen should have been what we replaced petrochemical with, because it would have been easy to convert the petrochemical industry to hydrogen, or converting it to solar. It just isn't happening, so it would have been a much viable approach. I think that ship has largely sailed, unfortunately, given our path down the lithium ion, or now lithium iron, now that we're talking about Ford's plant closing, battery technology. But boy, if we could have done something better there. We can still do it with regard to fleet vehicles and things like aircraft and large ships. The Lavo manufactures green hydrogen fuel cells that use solar energy and water to produce electricity. Hydrogen's output is largely water when it's used, so incredibly green. And then Electric Green it's a US-based startup that uses green hydrogen to charge fuel cell vehicles. Both great technologies that sadly came a bit too late, I think, to catch the wave, but could the consumer vehicle wave, but certainly in time for commercial vehicles and large-scale transport. Then a couple more. Advanced robotics. The Green Leap Robotics issue of solar panels is keeping them clean. That's something I'm dreading having to do, because you have to get up on your roof and with a squeegee and a little bit of soap and clean the panels off. Not something I plan to do anytime soon. Green Leap Robotics creates autonomous cleaning robots for solar panels, on my list of gifts for my 2027 Christmas. And Super AirVision provides drone-based blade diagnostics for windmills. Again, with these windmills, if you've seen some of the giant windmills, sending somebody up on one of those things to do maintenance is not. I mean, it's certainly going to pay well, but it's definitely a neat ticket ride in terms of scaring the crap out of anybody that's doing it. Using robots and drones to do much of that maintenance is a potential game changer for some of these turbines. And the Super Air Vision is the company that's making the drones that would allow this to happen. So a few companies, and all startups, most of them are based in the U.S., but some are based in Europe, working at it on existing methods and new methods to generate power with ever more sustainable and renewable mechanisms to solve problems that exist in our energy infrastructure. So I'd share that, and I'll pass over to David for his remarks. And remember, I've got to drop in 12 minutes. So
Yeah, Rob, thank you so much. I love the list of companies you went through on those. And, we're seeing other things with AI companies stepping in to play a much larger goal of optimizing some of the renewable energy. We're seeing material science stepping up big time to look at how to make, for example, transmission lines much more efficient and moving forward too. I love the bioenergy part though, and we've talked about these in many different ways with biomass and other types of ways to do it. But we're seeing tremendous advances there, as you kind of alluded to, with some of the things like cryogenics applied in them. We're seeing very advanced membrane substitution being brought in there, and things like bioethanol, others coming out of it. One of the others that I just think is really very interesting is a couple of European companies are working on making next generation fuel cells, and they're using paper-based fuel cell technology to begin to use it. Fuel cells is a technology that I thought was going to be more in the commercial sector by this time several years ago. Uh, there were multiple demonstration projects, I guess, 8 years ago or so, of putting fuel cells into cars, and that it really worked well there to make some of that work. And then you see grid integration really happening back there. One of the other projects that just kind of, again, I'm going to go back to my innovation theme here, is in California, they're doing something very interesting right now in renewable energy. Much of the United States, and including particularly California, has been in a drought. And California uses these large canals to move water for their farming and things, and they're open canals. And there's a startup there called Solar Aqua Grid, which is putting roofs over these canals to make it where they do not have as much of an evaporative loss every year. But these roofs over the canals are solar panels. And so they're using this approach of the space over these water canals to serve multiple purposes, to generate solar energy and cutting the evaporation. And the statistics on this one's real interesting. Is the state has about 6,500 kilometers of canals like this. And if this roof, the solar panel roof, was put over them, it would save over 283 billion gallons of water a year and generate power for about 10 million homes. Again, so a very innovative approach, I think, there. We've talked about this briefly in the past shows, and Rob, I apologize if you brought this up earlier. But I like the new trending we're seeing with solar powered windows. We're now seeing photovoltaics in such a way that I can code average windows and use that to generate power coming back into it. And it allows visible light but it absorbs and converts the invisible ultraviolet and infrared light into electricity. Uh, and the startup that is piloting that believes that that can generate about 30% of a building's total need. One we've talked about multiple times in this show in the past, and one that there are now many companies beginning to do this around the world, is we can generate water from air. And that is one where we're seeing, like I said, many different companies beginning to get in there and being able to uh, uh, have that type of response coming back with it. Um, a couple of other points on this as we're going down is there's, I'm putting on my futurist hat and kind of stepping back and saying, what are the type of things that you, the people listening to this program, need to look for coming up in renewable energy and renewable energy innovation? One of them is we're going to see the whole manufacturing process for renewable energy change a lot. In the past, pre-pandemic, it was concentrated in a couple places. You're going to see it begin to become more distributed. You're going to see more domestic manufacturing, not just in large uh, countries like the United States and EU, but increasingly in developing nations, you're going to see more domestic. You're going to see the trend going forward with, again, new ways to look at hydrogen economics. Rob talked about green hydrogen, which really has began to start again. There's now in many in the United States and a couple of other places a $3 per kilogram tax credit for clean hydrogen power that can be used in many different types. The green hydrogen, the gray hydrogen, there's quite a few others begin to get there. Uh, we're going to see a movement to help put additional funding. Part of COP27 was making funding available for developing nations. And we will see more of that, which will push this forward. I cannot talk about sustainable energy and innovation without talking about cybersecurity. There is tremendous cybersecurity risk in this area that many of these innovative companies are not addressing yet, but this is part of any country's critical infrastructure and needs to have cybersecurity. Uh, and there's just other trends, but one of the other ones that I've seen is there's this new generation of wind generation technology that is not using the blades. And there's ones which can attach to buildings that are like a vertical shaft without the turning blades. The company doing that is just a very innovative startup. There's uh, now wind turbines that are being combined with ships to generate electricity while powering the ship to power the propulsion system, an electric propulsion system, without having to use petrochemicals on that ship for shipping. In those same tall masts with their wind conversion on the ship can be used so many different places where the larger blades uh, present challenges. One of the places the large blade wind farms is present tremendous challenges is in bird migration pathways. Those blades kill thousands and thousands of birds during their migration path every year. So unintended consequences, but it's some of them that you have to begin to work through and understand the differences in there. The other one, which I kind of would like to kind of go back to, is one of the other areas which Rob touched upon earlier. And that is if you begin to look at the other advances you have in trying to create a hybrid solution. Rob talked about wind energy, he talked about solar energy, he talked about the advances in battery technology. Uh, I think he touched also upon some of the uh, grid integration technologies, but all of those can be combined with each other to create a hybrid solution. And I believe hybrid solutions are going to be one of the things that can help put us over the threshold of making this more sustainable to a wider marketplace. The solar by itself, you have to have the sun. Wind by itself, you have to have wind power. Uh, the battery technologies, well, they have their own challenges. Uh, some of the salt storage, some of the iodine storage and stuff is very interesting, but you actually need a hybrid solution to make it work well. That's why I like so many of these other ones combined. You heard me talking about the kinetic energy from trains. Well, let me not only use a little motor from that, but let me now put some solar cells on top of those freight cars, and I can generate energy multiple ways. I just need to string more battery cars along with that. Uh, oh, I can probably use the combination of the kinetic energy from the uh, tracks, the wheels going around, and the solar power to lessen the uh, carbon footprint of an engine by converting a dual powered engine where part of it can run off an electric engine as opposed to having to use the hydrocarbons to use the diesel or the other approaches that they're doing and make a hybrid solution there. Uh, as in most of the stuff we talk about in the program here, Dan, education is going to be a key part of it. And education and regulations have to be considered as you move this forward. But I want to just go back and oh, we're right at the top of the hour. I want to stress a point again. What will make renewable energy happen is the last part of the topic, title for the topic today, renewable energy innovation. We need to be innovative in this area. We need to really think about how can we look at new approaches. So often today, because Dan, you're going to hear my phrase again, we're in a systems of systems world. Innovation comes from areas outside the traditional industry's vertical segment we're looking at today many times. Let me take something from healthcare and throw it over in transportation. Let me take a biological process and, oh, I can now use it for energy innovation. Uh, there's so many different things. We look at the movement of water through our streams all the time. Well, can I do a low cost way to take advantage of the movement of water through the streams without disrupting the agriculture, the aquaculture that's there? Same thing. I applaud the company in California for thinking about putting solar panel roofs on top of those irrigation aqueducts. Great idea. I don't know what the return on investment is going to be yet, but I love the idea from both preventing the evaporation of the water and generating energy at the same time. And with those irrigation aquaways, you already have the right of way to do this. So you don't have to go out and procure a lot of right of way. So it lowers the threshold for that to be an innovative solution as you look at all of it in those elements. So, and I might just use that as my concluding remarks, is that innovation is what will drive a lot of this. It can be incremental innovation, it can be distinctive integration, which is the middle of the S curve, or it can be disruptive innovation, which is the top of the S curve. but it will take all of those different types of innovations for us to meet the targets that we're trying to look at for the zero emissions for the future. So Dan, concluding remarks, thank you.
Boy, that kind of leads right into what I'm thinking more and more about is, you read about these great innovations, and the article usually ends with, well, this is probably 5 or 10 years away from being commercialized, because they have to find a path to market. They have to pitch it to investors. They have to have a winning plan and all these things. So I just think we're kind of, holding ourselves back by not using more and more the private public partnerships, like so many things that can be accomplished using a government to kickstart the process aren't really being done enough. The patent system is pretty good, but if you build something that's you looked up the patent of something, you want to build your own copy of it, technically you're infringing on that patent. Of course, the odds of you getting in trouble for doing that are very low, but I would like to see more leeway in the regulatory space to encourage innovation, and I think that I'm working on some ways to do that, so stay tuned. So that was my concluding remarks.
So welcome back, Steve.
Yes, thanks. Good topic.
We both just finished concluding remarks.
So take us out.
Thank you, everyone. I request all of our audience, please share our content as much as possible, and request all of our speakers, please support our initiative. Thank you. Bye-bye and take care.
Take care, y'all.